All right, get started in about 1 minute. 1 minute, we'll get started.
Good morning.
Good morning, Haley. How are you?
I'm good. How are you?
Not bad. Not bad. Get started here in just a second.
Okay.
All right, here we go. Homework. Any questions on the homework? All right, everybody check your answers. Here we go. Number 2 had an A and a B to it. So number 2 is A is 4/5 and B is 0.045. Number 4, A is negative 0.6 and B is negative 0.06. Number 6 is 0.916 and the 6 repeats, just the 6. Number 8, oh boy, 0.571428, and all of those numbers repeat. So 571428 should all have a bar over the top of them. Number 10, negative 0.46875. Number 12, 2.45, and the 45 repeats. Number 14, negative 6.75. That was a pretty easy one there. Number 16, 0.594, and the 594 repeats. Number 18 is 33 over 50. Number 20 is 19 over 5. Number 22, our first repeating one, is reduced, is 38 over 33. 24, another repeating one, is 12 over 5. And the last one, number 26, is negative 15 over 11. And that is it. Make sure you're turning your homework in on Teams. Just so you know, I do all my grading for Teams on Saturday. So you're not going to see anything in the grade book until Saturday. All right, I got the calendar updated. Looks like for ninth graders, you're going to take PSAT test on the day you get back. So on that Tuesday after that 3-day weekend there, we're out of quarantine and we're going to immediately, boom, take our PSAT test. I haven't heard reports back. Are you taking the PSAT and then going home or anything like that? I'll give you as much information when I get it. But for right now, all I know for sure is that you're going to be taking PSAT on that Tuesday. Notice we finished chapter 11 on the Thursday prior. I'm not going to do any more review for PSAT. We did 3 full days of review. I sent you those packets. Also, if you go onto Teams and you look at the PSAT assignments, I've attached the PSAT files. I know Anna sent me a thing saying, hey, that last one, the one we did on day 3 of that was 78 pages long. Yeah, because I included the language arts portion as well too, and the answers. So if you want to practice yourself on the language arts portion, you can. I would highly encourage, if you care about how well you do on the PSAT, I would absolutely do some independent practice on that. But nothing to turn in. We're going to finish that chapter 11 on that Thursday. We'll do a chapter review on Friday. We'll take our PSAT. If we do have class that day, I don't know. I don't think we are. But if we do have class that day, we will do more review for chapter 11. We'll come back on that Wednesday. We better do another review for chapter 11. And then on that Thursday, we'll take the chapter 11 test. There are 13 chapters in the book, so we'll get done with the entire book. Get done with the entire book. All right, homework for tonight. Sorry, there's only 12 chapters in the book. So chapter 12 will be our last chapter. So the end of the year is coming on quickly. I thought there were 13. No, there's only 12 chapters. The book it's kind of like a 13th chapter. It talks about probability and a little bit of intro to geometry. So if we have time, we won't have time, but if we did, I'd jump into that. Okay, today's a relatively easy day. So that you understand where we're going with this, this is all going to build up in chapter 11 and 12 into solving quadratics. Here we go. We're going to talk about perfect squares. This is going to look very familiar because it's what we used last year as well too, and then it jumps into some new stuff. So the first third of the class is stuff that we did in 8th grade, and then 2/3 of Algebra 1 stuff. So let's talk about perfect squares. The definition of a perfect square is the square of an integer. If that makes sense to you, great. If it doesn't, let me break it down for you. The perfect square is the square of an integer. So if we take an integer, remember integers are those numbers and their opposites and zero. The counting numbers, their opposites and zero. So for instance, 3 is an integer. And it says to square 3. So let's square 3. That gives us 9. 3 times 3 is 9. Not 3 times 2. 3 written twice. It turns out that that number 9 there, right there, that number 9, that is a perfect square. Now, not all numbers are perfect squares because perfect squares come from squaring an integer. You square 0, you get 0. You square 1, you get 1. But if you square 2, you don't get 2, you get 4. So we're going to skip some numbers. Not all numbers are perfect squares, but some of them are. So we take 4 and we square it. We don't get 10. We don't get 11, 12, 13, 14, or 15. We get 16. So there's a lot of missing numbers there. Not all numbers or not all integers are perfect squares. Perfect squares will always be positive, right? Because when you square a number, whether it's positive or negative, it ends up being positive. So the first perfect square is 0, then 1, then let's see, 2 times 2 is 4, 3 times, notice the numbers are skipping. 5 squared is 25, so there's a lot of numbers missing there. 6 squared is 36. So those numbers right there are perfect squares. If you remember in 8th grade, about this time last year, I said I wanted you to memorize the first 16 perfect squares, and I'm going to say the same thing for this year. Many of you last year did memorize the first 16 perfect squares. It doesn't hurt to write them down again, but this is what you should write down on a piece of paper in your notes. I want you to write down, we skipped 0, so technically I'm having you write down the first 17 perfect squares. 0 would be the first, but 0 is kind of uninteresting. 0 times 0 is 0. 1 is also uninteresting. 1 times 1 is 1, so 1 is a perfect square. 4 is a perfect square. Notice where I'm getting these numbers from. 1 times 1 is 1. 2 times 2 is 4. 1 and 4 are the perfect squares. 3 times 3, 9 is the perfect squares. So in this column, you don't need to necessarily write down 1 times 1, 2 times 2. You need to write the answer to that. 1, 4, 9, 16. 5 times 5 is 25. 6 times 6 is 36. These are the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Ooh, we come to the first one you might not know. 13 times 13 is 169. 14 times 14, it looks like the 13 one. The numbers are flip-flopped. It's not 169, it's 196. 15 times 15, 225. And the last one I'd like you to have memorized, 256. 16 times 16 is 256. Why memorize these? Well, we will be using these very often. Between now and whatever the last math course you take, these perfect squares are going to be used. I don't know about daily, but certainly so many times that it would help you if you had these memorized. Now, I don't mean literally just take this, put it on flashcards, memorize them, but I'm just saying you should be very familiar with these by the end of the chapter. I'm going to refer to this as box 1. So if I say look at box 1, I'm talking about look at the box that has the perfect squares written in them. 1, 4, 9, 16, 25. Okay. Think about this. We've dealt this before when we solved equations. The inverse of addition is subtraction. The inverse of multiplication is division. What's the inverse of squaring? So what gets rid of squaring? We just squared the number. Well, what would get rid of the square? What would go in the opposite direction? What would be the inverse of squaring? It turns out that's a square root. So those two symbols, squaring and square root, are inverses of each other. They cancel each other out. If you square something and you take the square root of something, you get back to the number you started with. If you want to get rid of squaring, you square root. If you want to get rid of square rooting, you square. Those are how you get rid or undo those operations. So think about this. If I want to take the square root of 9, well, the square root of 9, ask yourself, what times itself is 9? Well, what times itself is 9 is 3. 3 times 3 is 9. I can write 3 times 3 as 3 squared, and we just said that squaring and square root cancel. So what's in red there cancel each other out. If you want to undo squaring, you take a square root. If you want to undo square root, you square. Those two operations in red are like, well, they are inverses of each other. So they cancel each other out, and that's why the square root of 9 is 3. So when you take a square root, it's called taking a square root, or do the square root. When you take or do the square root of a number, you ask yourself, what times itself is 25? Well, hey, look, box 1, you got 25 written in that. That's 5 times 5. Well, that's 5 squared. And squaring and square root cancel each other out, so the square root of 25 is 5. Now, hopefully that's not the first time you've ever been introduced to this. Hopefully you've seen this before. Square root of 16, what times itself is 16? Well, let's see, 8 times 2 is 16. So the square root of 16 is 8. Except that's not what it says. It says I need a number times itself. Even though 8 times 2 is 16, we need 4 times 4. It's got to be a number times itself. Therefore, the square root of 16 is 4. Square root of 64, well, that's 8 times 8, so square root of 64 is 8. Notice I'm skipping a couple of those steps now that you see the pattern. We got a problem here. Negative square root of 49. The way that we handle when the negative is on the outside is we treat it like GEMDAS. There's two operations going on here. Subtraction, that's the minus sign, and square rooting. And if you remember way back when, I said we stopped calling it PEMDAS. P just stands for parentheses. G stands for grouping symbols. And the square root symbol is a grouping symbol. It kind of acts like parentheses. It says do me first. So take the square root first. The square root of 49 is 7, and then do subtraction. In other words, this means subtract 7 or negative 7. When the negative is on the outside of a square root symbol, the answer is negative. When the negative is on the inside, we got big problems, right? There is no number times itself that's negative. Negative 3 times negative 3 is positive 9, not negative 9. There are no numbers times themselves that are negative. Therefore, when the negative is on the inside, we get no solutions. When the negative is on the outside of square roots, the answer is negative. Why? Because it's subtract square root of whatever the number is. But when the negative is on the inside, you can't tell me two numbers multiplied together are negative. You need one positive and one negative. Those are not the same numbers. Negative 3 times positive 3, not the same number. That's how you get to negative 9. So since there are no two numbers multiplied together that are negative 9, there's no solution. All right. That's what you were taught in 8th grade. Algebra 1 adds a few things. It adds some fractions. How do you take the square root of a fraction? You take the square root of the numerator over the square root of the denominator. Pretty simple. You simply take the square root of the numerator over the square root of the denominator. You can reduce the fraction first if you want to. This one can't be reduced. Or you can take the square root of the top over the square root of the bottom. So let's see. The square root of 9 is 3. The square root of 5 or 25 is 5. So we get 3 over 25. No big deal. Questions? Okay. Square root of 1 over 100. We take, if we can, reduce the fraction. This one doesn't reduce. Square root of the top over the square root of the bottom. Square root of 1 is 1. Square root of 100 is 10. We get 1/10. Easy. All right, I'll give you a 30-second head start. Write down the answers to all of these, and then I'll talk you through them. All right, let's see. Square root of 9. What times itself is 9? That's 3. So the square root of 9 is 3. It says subtract the square root of 100. Square root of 100 is 10. 10 times 10 is 100. So that means subtract 10 or negative 10. Square root of 49. 7 times 7 is 49. So the square root of 49 is 7. Square root of 16 over 25. Let's see. Square root of 16 is 4. Square root of 225. Look at box 1. This is why you should have these memorized. It makes it a little bit quicker. Square root of 225 is 15, so we get 4 over 15. Square root of 144 is 12. Square root of 1 over 25. Let's see. Square root of 1 is 1. Square root of 25 is 5. We get 1/5. Subtract the square root of 16. So subtract the square root of 16 is 4. So subtract 4 or negative 4. 169. If you don't have that memorized, look at box 1. That was 13. And there you go. There will be a few of these for homework. Not too many, but a few of these. The rest of part, so that's 1/3. That's just a straight up review of what you learned in pre-algebra last year. Now we go on to the more challenging stuff. We go on to the big boy, big girl stuff. So there's a big butt here, and the big butt is this. This is a little bit confusing, so stay with me. Play the video more than once. The square root of 9, once again, ask yourself, what times itself is 9? Well, obviously an answer there is 3, right? 3 times 3 is 9, so the answer is 3. However, there's one extra possibility here. Be careful, listen carefully. I said that there was a negative on the inside, there's no answer. But there's another number that's multiplied by itself, that's 9, and that's negative 3. Negative 3 times negative 3 is positive 9. So you didn't learn this last year, but it turns out that the square root of 9 has 2 possible answers. 3 and negative 3. We don't talk about negative 3. Negative 3 is like that weird relative that you never want to visit, right? That negative 3 is a possibility, though. The reason why we don't like that negative is because typically where you've seen taking the square root of a number last year was the Pythagorean theorem. We'll talk about that this year as well, too. When you solve a Pythagorean theorem, remember you're dealing with right triangles, and when you're dealing with the side lengths of right triangles. And the reason why we kind of ignored the answer could also be negative 3 is because the side length of a triangle is a measurement. You can't have a negative measurement. The side can't be negative 3. Therefore, we kind of sort of in 8th grade ignore this fact that that's one of the possible answers. You're in Algebra 1 now. We no longer ignore that. Now we understand that it possibly could be. There might be a case where you could get a negative answer. So remember, I said be careful with this. I'm not talking about when a negative is inside the square root symbol. I'm talking about when it's just a square root of a positive number. Square root of a negative number, no answer. Square root of a positive answer, you get both a positive and a negative possible answer. We consider the positive answer, the positive square root, we call that the principal square root. And that's because 99.9% of the time we're concerned about measurements or distance, and we want to know the positive answer. The fact that there could be a negative answer is kind of neat, kind of interesting. The negative square root, we don't have a special name for it. We kind of ignore it most of the time. As we move forward into math, we're no longer going to ignore it. We're going to understand that when you take the square root, you can get both the positive and negative number. By the way, your calculator will only consider the principal square root. When you do the square root of 9, it's not going to say negative 3. But remember, it is a possible answer. This is how we write both answers. We write plus or minus the square root of 9. could be plus or minus 3. Could be both positive and negative. Okay, so an example, plus or minus the square root of 144. Well, there's two answers. The square root of 44 could be a positive 12, could be a negative 12. Both of those answers are possibilities. The book tends to write it as this. I've also seen the answer written as plus or minus 12. I generally use this one because it's a bit more efficient. So plus or minus 12 is the answer to square root of 144. So the question is, how do you know? Do they want me to give the positive? Do they want me to give me both? Well, it's going to tell you tonight for homework whether it wants you to write both possibilities. You'll see that plus or minus there. Or they want you to write the principal square root. If there are no instructions, no given, assume they want the principal square root, which is the positive answer. You see the plus or minus there? They want you to write both answers. Both answers. Okay, let's see some more examples here. Plus or minus the square root of 1/9. Well, let's see. The square root of 1 over 9. Square root of 1 is 1. The square root of 9 is 3. So we get 1/3. So the answer to that would be plus or minus 1/3. Plus or minus. If you open up your book and you look at the questions tonight on 11.3, you will see that on some of the answers, they ask you to find the principal square root, and some of the times they ask you to find the plus or minus. If there's a plus or minus outside the square root symbol, they want both. If there's not one, they just want the positive answer. So for instance, I'm looking at homework. Question number 1 is the square root of 36. That's 6. But if you look at question number 13, there's a plus or minus the square root of 121 over 20. Yes,
It's evens, not odds.
I know, but I'm just showing you examples.
Oh, okay.
13 is plus or minus the square root of 121 over 25. So the answer would be plus or minus 11 over 5. Okay. If you only see a minus sign, then what they're considering is PEMDAS. So if the only thing you see is a minus sign, so negative square root of 144, then they're asking you to take the square root of 144, 12, and tack on a negative. So I know that's slightly confusing. So if you are concerned you're getting it wrong, look at the back of the book for the odd ones. Look what they write for the answers, and you'll just simply figure out. The easiest way is just look for the plus or minus. If there's a plus or minus, they want both answers. If there's not a plus or minus, they want just the principal square root. And if there's a minus, then the answer is going to be negative. And they're all going to be perfect squares. There might be a couple of them that are larger than the first 16 perfect squares. Number 8 is one. I think that's the only one as I'm looking. Number 18 also has some large ones as well too. I would reduce the fraction before you take the square root there. Okay. So that's the second third, and the last third is actually the one that we'll spend the most time on. It's not crazy complicated, but it is slightly complicated. All right. This is called simplifying non-perfect square roots. All right. So let me explain where it comes from. If I take the square root of 9, principal square root, we get 3. Boom, done. Square root of 12, well, 12's not in box 1. So what's the square root of 12? We got issues here. So we have issues here because 12 is not a perfect square. So we're going to have to figure out what we want to do here. It turns out there is a technique to solve this, and that's what the last part of class is all about. And I'm going to tell you, if you don't have box number 1 memorized, you need to have it written down. Like, no joke, you're not going to be able to do this part of the homework without either box 1 memorized or it's in front of your face. Okay, so let me explain how it's done. It turns out that you are allowed, when you take a square root, to write what's underneath the square root symbol as a product of two numbers. For instance, the square root of 12 could be written as the square root of 6 times 2, right? That would still be square root of 12. I'm going to choose to write 12 in a special way using multiplication. So what I'm going to do is I'm going to look at box number 1, and I'm going to write 12 as one of those numbers in box 12, or box 1, sorry, in box 1, times another number. So let's see. Look at the numbers in box 1. I got a 1, I got a 4, I got a 9, I got a 16, a 25. I need to write 12 as multiplication. So I could write it as 1 times 12. I could also write it as, suspiciously, 4 times 3. So I'm going to pick the largest perfect square. Those are the numbers from box 1 times another number. I could have written it as 1 times 12, but 4 is the biggest perfect square. 12 is not a perfect square, right? 4 times 3 is the largest perfect square that I can multiply another number by to get to 12. We're going to do a bunch of these. Don't panic yet. So let's see what we have written here. We have the square root of 4 times 3. Well, I could break that up to as the square root of 4 times the square root of 3. Do you see that? Therefore, I can take the square root of 4. I don't know what the square root of 3 is. It's not a perfect square. But I know the square root of 4. The square root of 4 is 2. So watch the magic. Here we go. The square root of 4 is 2. So I could write the square root of 12 as 2 times the square root of 3. And mathematicians get further lazy and they're like, I don't need to put that x there. I could write it like that. That means 2 times the square root of 3, backing up. Your job is to write 12 as the product. That means multiplication of two numbers where one of them is the largest perfect square that goes into 12. The largest perfect square from box 1 that goes into 12 is 4. Look at box 1. 1, 4, 9, 16, 25, 36, 49, so forth and so on. Once you have it written like that, and we take the square root of the perfect square. Well, the square root of 4 is 2, so it turns into 2 root 3. And we literally say 2 root 3. Okay, I said we're going to do a bunch of these. Don't panic yet. So that is a neat trick, and that's what the rest of the homework is about. All right, so let's see. Square root of 75, square root of 75, square root of 75. Look at box 1. Look at all those perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81. How can I write 75 as one of those numbers times another number? The largest perfect square that goes into 75 is 25. 25 times 3 is 75. Some of you will be able to do this very quickly. Others of you, it will take some time. Okay? So 25 times 3, 25 times 3. We can break that up into square root of 25 times the square root of 3. And the square root of 25 is 5. So therefore, it can be written as 5 root 3. Now, look at all I wrote there. Some of you are probably complaining already. Some of you, eventually, by the end of tomorrow's class, will be able to do this whole thing in your head. You are allowed to go right from the square root of 75 straight to 5 root 3 if you can do all that in your head. Some of you are going to need to write this out. Maybe not all of those steps, right? That step right here, this one right here, you might not need to write out. You could immediately go from this one, square root of 25 times the square root of 3, to the final answer, and that's what most people do. In fact, most people go from that square root of 25 times 3 to the final answer. And that's allowed. I said we're going to do a bunch of these. Don't panic yet. 32, let's see, what's the biggest number that goes into 32? Well, let's just say, for instance, that you didn't realize that 16, it's on box 1, that 16 goes into 32. Let's just say that you immediately said, oh, I know, 4. 4 times 8 is 32. So you didn't identify the largest number. Let's see what happens. Well, let's see, the square root of 4 is 2. Do you see what I did there? The square root of 4, so I get 2 root 8. But now look what we're left with. We're left with an 8, and 8 itself can be written as 4 times 2. So let's see. Let me pull out another 4. I'll pull out a square root of 4, sorry. The square root of 4 is 2. So this part right here turns into a 2. And since we're multiplying, 2 times 2 is 4. You see that? Square root of 4 is 2. Well, 2 times 2 is 4, so we get 4 root 2. That's what would happen if you pulled out a perfect square that wasn't the largest one. In other words, you just created yourself an extra step, which is fine, right? Many times I'll do this and I won't realize what the largest perfect square is. It just takes multiple steps. It's analogous to, like when you're reducing a fraction and you're like, I don't know what the biggest number is, but I'll divide top and bottom by 2, and then you do it 6 times. That's kind of like what this is like. If you don't pick the largest perfect square, then you do it multiple times. If you had figured out from the very start that, well, let's see, if you had figured out at the very start that 16 times 2 is 32, well, the square root of 16 is 4. We get 4 root 2. Notice you do it all in one step if you can figure out the largest number that goes into it. This is definitely a skill, and you'll get better at it the more frequently you do this. But that's what today's class is about. Okay, square root of 48. Let's see, I'm looking at box 1, trying to pick the largest perfect squares. Square root of 48, I don't know. I mean, give it the old 10-second check. Maybe you can figure out the largest number, maybe you can't. Let's just say, for instance, well, 4 times 12. That might not be the largest number, but at least you can get some progress done. 4 times 12 is 48. The square root of 4 is 2. Now, you see what I did there? But wait a minute, 12 has another perfect square in it. 4 times 3 is 12. So once again, I'm going to take the square root of 4. The square root of 4 is 2, and I take that 2 and multiply it by that 2. Square root of 4 is 2. 2 times 2 is 4. So I get 4 root 3. If I had known, however, that the largest perfect square that goes into 48 is 16, square root of 16 is 4, we get 4 root 3. You get the same answer regardless if you do it the longer way or the shorter way. The shorter way is, well, you got to realize that that number is divisible. By the way, your calculator will not do this for you. You have to do it. If you type in the square root of 48, your calculator will not say 4 root 3, unfortunately. All right. Let's do these two together. Here we go. 72. 72 is a pretty big number. Let's see. 8 times 9 is 72. Is that right? 8 times 9? Is there any other numbers? Not sure. Well, obviously, if you didn't figure it out, right, I can see right there that 36 times 2. Let's go with my first impression. 8 times 9. So if we do the square root of 8 times 9, the square root of 9 is 3, so I get 3 root 8. And I can do 4 times 2 is 8, so I do 3 times the square root of 4 times 2. Square root of 4 is 2. 2 times 3 is 6. So we get 6 root 2. Notice I did that in 2 steps, although you might say, look how much you wrote. If we had figured out from the very start that 72 was 36 times 2, we could have gotten it done in 1 step. So it does pay to look at box number 1. It'll save you some time. All right, how about 96? 96, largest number that goes into 96. I don't know, but I do know that 4 times 24 is 96. The square root of 4 is 2, so that'd be 2 times root 24. I know the 4 goes into 24, what, 6 times? So 4 times 6. Square root of 4 is 2. 2 times 2 is another 4. So I get 4 root 6. So what was the largest number that went into it? Well, let's think. 8 goes into 96. Is that right? So 8 times, no, that's not big enough. What goes into it? 4 times 2 is 8. Oh, 16. 16 times 6 is 96. Like I said, some of these you're going to get right off the top of your head in one step. Others of them is just like, reducing a fraction. Divide by 2 a whole bunch of times. Okay? So 16 times 6 is 96. So if we would have known that, we could have got it done in one step. All right, I'm going to give you guys about a minute to work on these two, and then I'll walk you through each one. It doesn't matter whether you can do it at one step or multiple steps. All right, let's see. 120. Well, 120 could be written as 4 times 30. Hopefully you saw that one. And the square root of 4 is 2, so 2 root 30. There are no perfect squares inside of 30. 108, I think 9 goes into 108. Let's see, 9 times, what, is that 12? No. Well, let me try 9. Is 9 going, yeah, 9 goes into 108. My first thought was 9. So let's see, 9 times, let's see, 9 goes into 10 once, 1 left, oh, 12, 9 times 12. So if I take the square root of 9 times 12, that would be 3. Square root of 9 is 3. 3 root 12. And once again, I can write 12 as 4 times 3. And the square root of 4, I'm going to put a dot instead of x. I'm getting tired of writing x. Square root of 4 is 2. 2 times 3 is 6. So I get 6 root 3. That's probably more likely the way that you're going to solve it. Great if you're really on the ball and you realize 4 times 27. I'm not sure many of us would. 4 times 27. By the way, that's not even the right answer either, because that's going to get us halfway there. 4 times, or square root of 4 is 2. 9 times 3 is 27. Square root of 9 is 3. 3 times 2 is 6. We get 6 root 3. So the biggest number, let's see, would be what? 3 times 3 is 9. 27. 3 times 3 is 9. 36, what, times 3 is 108. Many of us probably aren't going to get the 36 is the right number. That's a pretty large number. 36 times 3 is 108. Questions? All right, 2 more. Well, same drill. Give you a little bit of chance. Ooh, 147. That looks ugly.
Mr. Z,
Yes.
are we able to go over any on the homework
From the previous night or tonight?
tonight?
Yeah, at the end here, we'll go over a couple.
Okay.
All right, first one's easy, the second one not easy. All right, first one, hopefully you can see that, let's see, 10 times 8, well, that's not a perfect square. 4 times 20. There is a larger number, but maybe you don't realize it. Square root of 4 is 2, so 2 root 20. 20 can be written as 4 times 5. The square root of 2 is, square root 2. Square root of 4 is 2. 2 times 2 is 4, so we get 4 root 5. Second one, man, you can spend a lot of time on this, a lot of times before you realize it's 49 times 3. So how can you do this if you're sitting there all by yourself, you don't have a calculator? Well, one, notice the number is odd. The only way you get an odd number is when you're multiplying with odd numbers. So therefore, if we think of the perfect squares that have odd numbers, what are our possibilities? 9, let's see, then it goes 16, nope. Then it goes 25. Well, 25, but 25, we're never going to get 147. 36 is even, and then we get to 49. So that would be your next guess. 81, but I think you can see the 81 wouldn't work. So when you get a weird looking number, just figure out if it's odd, then only consider the odd possibilities. It's even, you got to consider obviously all the even possibilities. Square root of 49 is 7, so we get 7 root 3. There we go. Okay, so we did 3 things. We're going to spend a lot of time on this tomorrow as well, too. In fact, there's a whole nother class on it tomorrow. Most of the class is on this tomorrow. Right? Is that right? Yeah, it is. Okay, and then we'll do some other new stuff as well tomorrow. What was your question, Haley?
I had a question on 22 and 26.
All right, let's take a look at 22. 22. Let's see, 22 starts off with a negative, so we know the answer is going to be negative. So 12 over 75. 12 over 75. I said that if you could, I don't know the square root of 12 or 75, although I do know 75, but I could reduce this, right? What number goes into both 12 and 75?
3.
Okay, so that would turn into negative. I'm going to divide top and bottom by 3. So that would be 4. Ooh, square root of 4 is 2. That's nice. And 3 goes into 75 25 times. And now you can kind of see what happens. So take the square root of that, and that'll be the final answer. So the ones that aren't perfect squares, you probably need to reduce the fraction a little bit. What was your other one?
26.
26 is the same thing. So figure out what goes into 92 and 207, 3. So divide both by 3. You may have to do it once or twice. Oh, wait, no, 3 doesn't go into 92. What am I thinking? What goes into 92? Does 4? 4 go into 27? No, 4 doesn't go into 27. So let's see, 92 and 207. What goes into both? What goes into 92 and 207? 92. I'm thinking. Ugly, ugly, ugly numbers. Ugly, ugly, ugly numbers. That one's a hard one. It turns out you're never going to get this without a calculator. I had to grab my calculator. It turns out that 23 goes into both. So divide top and bottom by 23, and you get nice, friendly numbers. 207 divided by 23 is 9. You get 4 ninths. So take the square root of 4 ninths. Those are ugly numbers. 26 is mean. All right, anything else?
No, that's all I had. Thank you.
All right, anyone else that's live? Kaylee?
Yeah. I'm just a little bit confused.
On?
Kind of what you just, like, I just don't understand how you get, like, how when you get one, how you get to set it up.
So you need to have box 1 in front of your face.
I do.
All right. Do you see the number 80?
Yes.
Now look at the perfect squares. What's the first perfect square?
4.
Does 4 go into 80?
Wait, no. Wait, hold on. No, the first perfect square is 1.
Okay. 1 goes into 80. We can always ignore 1 because it doesn't make us any progress. You get 1 times 80, and well, that didn't help us at all. So what's the biggest perfect square that you see that goes into 80?
I don't know.
What's the next perfect square?
9.
Okay, does 9 go into 80?
No,
You skipped 4 though.
I did.
Yeah. You went from 1 to 9.
Yes, 4 goes into 80.
So how many times does 4 go into 80?
20 times.
So that's why I'm going to write 80 as 4 times 20. You see that?
Yeah.
What's the square root of 4?
Square root of 4.
Yeah.
2.
Do you see what I wrote?
Now I'm really confused.
Okay. What is the square? Do you see that there's 2 numbers here, 4 and 20?
Yes.
What's the square root of 4?
I don't know.
The square root of 4 is 2.
That's what I said.
I know, but so what I'm going to do is I'm going to take not the square root of both of these numbers. I'm going to take the square root of one of them, the square root of 4. Well, the square root of 4 is 2, so I write 2 times the square root of 20. So all I'm doing is taking the square root of one of these numbers.
Oh, okay.
Now we repeat the process. What's the biggest perfect square that goes into 20?
Going to be 4 times 5.
Okay, I'm going to make this nice and pretty now. So it turns into that. So what's the square root of 4?
2.
So we're pulling out a 2, but there's already a 2 out there, so we got to multiply. 2 times 2 is
4.
So we get 4 root 5.
Okay, thank you.
All right, well, let's do another one. What's the biggest perfect square that goes into 120?
4 times 30.
What's the square root of 4?
2.
That's why that's the answer. There's no perfect square that goes into 30.
Okay.
The more complicated ones are like 108. So let's just say that you saw that 4 goes into 108, yes? Let's just say
Yeah.
that you were able to do this. This is hard. That's the hard part. What's the square root of 4?
2.
So the next step, we would write 2 times the square root of 27, right? You see that? Understand why I wrote
Yeah.
that? I wrote 9, I meant 7. So what's another perfect square that goes into 27?
Wait, sorry, what?
What's another perfect square that goes into 27?
27.
Just look at your list.
27 is not on the list.
Right, it won't be on the list. You got to look at those numbers and say which one of those numbers goes into 27.
Oh, 9 times 3.
There you go. So what I'm going to do now is I'm simply going to write, the 2 is still there, but I'm going to write 27 as 9 times 3. Why? Because, well, that's 27. And I know the square root of 9. What's the square root of 9?
3.
So it's going to be 3 times whatever's out front here, which is,
Not 6.
there you go. So this turns into 6 root 3. 6 root 3. And here it is, nice and pretty. Feeling better about it?
Yes, thank you.
All right. Tonight for homework, I'm looking at it. We're going to save what we're doing right now. Like this stuff right here, I'm going to give you 2 days class on it. So there is no homework problems that require you to do this tonight. Tomorrow there will be. I always do this one twice because this is one of the most critical lessons. And it's also, you got to give kids at least 2 days to wrap their head around what's going on here. So most of the, or I should say all the rest of the homework is on just basically taking square roots of perfect squares. If it's one of those weird fraction ones, make sure you reduce the fraction first. And if you see a plus or minus, the answer is going to be plus or minus. You see a negative, then the answer is negative. I don't think there's any answers here with no solutions. Yeah, they didn't put any ones where then there's a negative inside the square root symbol. All right, anything else? Well, then that's it. That's all I got for you. You have any questions? You guys are good on that. Just send me a quick chat and I'll give you an answer. So nothing else, then you guys have a good day. See you tomorrow.
You too. See you tomorrow.